Hi everyone. In this video we're going to be proving some arguments valid using proofs using the two new rules that we've learned from the previous video, which are addition and simplification. So let's take a look at this argument. So there's a bunch of kind of complicated looking statements here. We might not know exactly where to start. So when you're a bit unsure about where to start, you can start by looking at the conclusion. So conclusion is a G. So we see J or G here, so from that alone we can tell that we might be able to get a G through disjunctive syllogism. If we get a G through disjunctive syllogism, then we'll need a not J. So do we see a J anywhere? Over here I see a J then K. So if I can get a not K, then I can get a not J. I see a not K right here. Before I can get this J then K, I need to get this P and Q then R. I need to get that to go away. I see it's P and Q then R or J then K. So if I could set up a disjunctive syllogism, then I can get rid of that. So now that we have some idea on how to solve this argument, let's get started. So looking at premises 1 and premises 3, I can both do simplification on either of those premises. I think I'm just going to start with premise 1 though. So I'm just going to copy this here. I'm going to copy it and paste it. So I'm going to get not P and Q then R. And I'm going to add a bracket right here because I didn't copy it. I get not P or Q then R. And I'm going to get that through one simplification. Now that I have not P or Q then R, I'm going to get J then K. And I'm going to get that through 2, 5 disjunctive syllogism. Now that I have J then K, I'm going to get not K, and I'm going to get not K through 3 simplification. Now that I have not K, I'm going to get not J through 6, 7 modus tollens. And now that I have not J, I can get G using 4, 8 disjunctive syllogism. So let's take a look at what I did here. I might have gone a bit too fast. So using premise 1, I simplified it and I got rid of the conjunction on the right side. So instead of not P and Q then R and L and Q then R, I just got not P or Q then R. After I got not P or Q then R, then I did a disjunctive syllogism using premises 2 and 5. So premise 2 is remember, the disjunctive syllogism, you can just think, you see, there's all this stuff right here, but you can just think of this as a P on the left side, or the left disjunct as a P, and the right disjunct as a Q. So either P or Q, we get not P in premise 5, and therefore we get Q, which is J then K. Now that I have J then K, I want to get a not J. So premise 3 is not K or L or Q. I can just simplify to get not K. Once I get not K, I can use the modus tollens. So if J then K, not K, therefore not J. So I get a not J right here. And after getting my not J, I can just do the last disjunctive syllogism I need. Similar in the way in premise 2 I did the disjunctive syllogism, the disjunctive syllogism is also going to work the same way. So either J or G, not J, therefore G. And that's the conclusion that I was trying to get. So I want to do one more practice problem. This one is a little bit harder, but hopefully I'll explain it clearly enough that you'll understand it, and hopefully it'll be good preparation for harder problems that you'll have to deal with in proofs. So let's get started with the next problem. Okay, so let's do this. Alright, so this argument has a lot going on. It has not L, then Q, then P. So that looks like it might be a modus ponens. I see P right here. I can do addition, P or R. Okay, so that probably works with premise 2 for addition. Give me not L. Then I see the not L. I can get this not L, then Q, then P. Another thing I see is with premise 3 and 1, I can set up some type of hypothetical syllogism. And that hypothetical syllogism looks like it works in play right here, and it takes me to this L and P, and my conclusion is not Q. So again, working from the conclusion, let's see, how would I get a not Q? Well, I see q then p here twice, but this statement is already within this other statement. So somehow I'm going to want to get a q then p by itself. So I see this q then p right here, and I see this not p right here. So it tells me that if I can get this q then p and then this not p, I can get a not q. And then so all I'd have to do is get not p first. So let's work on trying to solve this argument. So the first thing I'm going to do is I'm going to hit p or q, and I'm going to get that through to addition. Now that I have p or q, I'm going to get not l. I'm going to get not l through premise 3, 5, and modus ponens. Now that I have not l, I'm going to get q then p. So I'm going to get q then p through premises 1, 6, modus ponens. Now that I have q then p, I can't do anything else with that last statement because I don't have a q yet, and I don't have a not p yet. So let's see what else I can do. I've used every single statement except for premise 4. I've used every single premise except for premise 4. That's the only one I haven't been able to touch yet. So I see premise 4 is p or r, then q, then p. So that's the antecedent. So looking at premises 1 and 3, I can get that through hypothetical syllogism. So I'm just going to go ahead and copy this right here. I'm just going to copy it, and I'm going to get that through premises 1, 3, hypothetical syllogism. Now that I have this, I can get not L, then not L, then not P. And I'm going to get this through 4, 8. I'm going to get this through 4, 8 modus ponens. And now that I have this, I can get not P, and I can get this through 6, 9 modus ponens. Now that I have not P, I can get not Q. Not Q, which is my conclusion, and I get not Q using, I can actually do a few things here to get not Q. I can actually use premise 5 and premise 10 and get a disjunctive syllogism, or I can use premise 7 and premise 10 through modus ponens. So whichever way works. I'm just going to use 7 and 10. So I'm going to use 7, 10 modus tollens. And in a similar way, so the first thing I started off by using P, and then I got P or Q through addition. Then once I added this, I could use P or Q, then L, P or Q, therefore P or Q, therefore not L. And I had P or Q, therefore I get not L. Once I have not L, I can get Q then P through premise 1. And once I have Q then P, I can't do anything more. But after that, I can use this hypothetical syllogism using premises 3 and premise 1, using this not L as a link to link them together. And then I get P or R, then Q, then P. And once I have that, actually these brackets aren't supposed to be here. Yeah, these brackets aren't supposed to be there in this one. So I get that. I get P or R, then Q, then P. And then once I get that, I can do the modus ponens, P or R, then Q, then P. Then not L, then P, then not P. Then I can get not L, then not P by using that right there. And once I get not L and then not P, I can use the previous not L which I got to get not P. Once I have not P, I can get not Q either through 7, 10 modus ponens, if Q then P, not P, therefore not Q, or using 5, 10 disjunctive syllogism, P or Q, not P. Actually, no, that wouldn't work actually, that's completely wrong, because this is P or Q, so by getting not P, I'd get Q. And Q is not what I want. So as you can see, this is how you prove this argument. And so I just wanted to give you a bit of a harder argument, just so you'd know what it would look like. And So yeah, in this rule we covered arguments using the two new rules of replacement, that the two new rules of inference that we've covered, which are addition and simplification. And so that's it for this video, and I'll see you guys in the next video.